दोस्तों जय हिंद जय भारत नमस्कार। In continuation with our discussion related to the physics standard 12 central board examination course, in this particular topic, in topic number 3, we will try to understand the properties of an electric charge. It means the electrical charge, what are the properties and how can we understood this property one by one. I will try to explain. So students should understood this particular lecture very carefully. What are the properties of an electrical charge? But before going to that, let me again, any charged body consists of two type of charge. One is called a positive charge and second is called a negative charge. We discussed lot many things in last two sessions. Any charged body is consist of a positive charge and a negative charge. Positive charge I have then mentioned as a red dot, and then the negative is a blue one. Now there is a distance between the two charged particle. Now listen carefully. If the size of the 2-point charge is too small, if the size of the two charged particle is too small, you can see here the two charged particle, the size is too small compared to the distance. The distance is quite large, but the size is too less, and that is why this type of charge is declared as a point charge. I repeat again, if the distance between the two charged particle is too large compared to their size, the size is quite less here, but the distance is too large, and that is why it is been declared as a point charge. Moving further, the charge has a magnitude, but there is no direction. Any charged particle has defined as its own magnitude, but there is no direction. Can we say this is just like a unit called mass? No. In mass, the body is always positive. If you define any mass unit in body, if any mass of any body, it will be always positive. But in case of charge, the unit either a positive or maybe a negative. So this is the difference between mass and a charged body. A charged body has a magnitude but no direction. Beautiful discussion. Moving further, property number 1 of any charged body. Property number 1 of a charged particle rather than say charged body, charge can be additive. What does it mean? I have two charge point and there is a distance. That means the charged body always mentioned with a proper sign. Point number 1. The first property of the charge is always it mentioned as a +1, +2, +3, -5. That means when you mention the figure, it must have a sign either positive or either negative. -2. But how can we calculate the total addition of a charged body? If any body consists of any charge, how can we edit the charge? Let me try to explain. There is one particle consists of +1, +3 and -2 charges on the bottom corner. The total charge of the body is equal to +1 plus +3 plus -2. The net result is +2. That means you can add charge as mentioned. +1 plus +3 plus -2 is equal to. So this is all about the charge body. Charge body addition is possible. How we have seen in last slide. Property number 2. Charge can be conserved. What does it mean? We took two material rubbed together. Once you rub together, the many electron will jump from one body, or either I can say electron will transfer from one body to the another body. Now from the one body to another body, the electrons are being transferred. One body lost the electron and the second body received the, or we can say second body gained the electrons. In this particular, you can see here, charge cannot be destroyed or charge cannot be created, but it can be transferred. Property number 2. Charges cannot be destroyed, not be created, but it can be transferred. Many times our nature creates the charged particle called neutrons, and neutrons consist of protons and electrons. The neutrons turns into protons and electrons. The protons have a positive charge and neutrons have a negative charge, the protons and electrons have equal and opposite charge. That means the net result is 0. The neutrons are always neutrons having there is a 0 charge. Neutron consists of protons and electrons which have equal and opposite charge. Hence the net result is 0. Beautiful explanation. Moving further. Property number 3. Charge can be quantized. What does it mean? I have mentioned one particle consists of proton and electron. The charge of any body is defined by a letter called a small q, and it is nothing but n into e. N is any integer, either a positive or a negative. Positive for the protons and negative for the electrons. The charge of electrons defined as minus e, whereas the positive protons is plus e. Excellent explanation. The electric charge always integer multiple called quantization of the charge. Means the quantization of charge first established by the Faraday during its electrolyzation process. The scientist Faraday has found out quantization of the charge during the electrolyzation process. And in 1912, Mr. Millikan established the same by practical too. In 1912, Mr. Millikan, a second scientist, established the same. The charge of any body is defined by a q is n into e. N is any positive, any integer number, and it is positive for the protons. It is positive for the protons and negative for the electrons. But in the international system called SI unit, the charge is defined as a coulomb C. What does it mean? Let us take one copper wire, what I have mentioned in yellow. The current passing through this wire is 1 ampere. The current passing through this particular wire is 1 ampere. The 1 ampere flow in 1 second. The time taken by this particular current to reach from one end to second end is 1 second. Repeat करता हूँ. There is a copper wire. Current passing through this wire is 1 ampere in 1 second. If the total charge flowing through the wire is called 1 coulomb, means 1 ampere passed in 1 second. Excellent understanding. How can we understood the coulomb? 1 coulomb means a 1 ampere current flowing through the wire within 1 second. The charge flowing is declared 1 coulombs. The value of basic unit of E is 1.602192 into 10 raised to minus 19. This is the value derived. The 1C charge consists of 6 into 10 raised to 18 electrons. It is too large in size. So many times we define 1 coulomb. 1 coulomb is equal to 6 into 10 raised to 18 electrons. And that is why this is a big unit. So we are supposed to define this 1C many times millicoulombs or microcoulombs 10 raised to minus 3, 10 raised to minus 6 also. All about the coulombs. Now let me give one example. One body consists of N1 electron and N2 protons. The total charge is N2 multiplied by plus E plus N1 multiplied by minus E. The net result is N2 minus N1 into E. What does it mean? I have mentioned one beautiful picture on the bottom side. If 10 raised to 9 electrons, let us take one example. On the bottom side, 10 raised to 9 electrons transfer from one body to second body in 1 second. How much time it will take to get 1 coulomb charge? The question is, from the one body to second body, 10 raised to 9 electrons move every second. How much time it will take to reach 1 coulomb charge? Let us resolve the problem. The charge of an electron is 1.6 into 10 raised to minus 19. What we have explained in the last slide. One electron charge is 1.6 into 10 raised to minus 19. But in this particular question, in 1 second, total 1.6 into 10 raised to 19 multiplied by 10 raised to 9 electrons are moving. Repeat again. In 1 second, 10 raised to 9 electrons are moving. An electron charge is 1.6 into 10 raised to minus 19. That means total electron moving from one body to second body is 1.6 into 10 raised to minus 10. The time required for 1 coulomb charge is 1 coulomb divided by 1.6 into 10 raised to minus 10. This is the 1 coulomb time required. To reach 1 coulomb, how much time is required? That is the question. So 1 coulomb divided by 1.6 into 10 raised to minus 10. That much electron will flow. So total output is 6.25 into 10 raised to 9 seconds. In 6.25 into 10 raised to 9 seconds, the particular material will declare 1 coulomb charge. If we convert the seconds into year, it's supposed to be approximately 200 years. That means 198 years. After 198 years, this is declared 1 coulomb charge. If 10 raised to 9 electron will transfer in 1 second from one body to second body, after 198 years, this particular system declared 1 coulomb charge. What we did, students? We consider a charge of 1 electron. How many electrons are flowing? 10 raised to 9. We multiply with 10 raised to 9. We got a total charge. Now to reach 1 coulomb charge, how much time is required? That was the question. So 1 coulomb divided by 1.6 into 10 raised to minus 10. We got approximately 1 after 198 years. This particular will declare as a 1 coulomb. This is the beautiful example to understand the coulombs. Thank you. We will continue this discussion, Coulomb's law, in the next session. धन्यवाद.